And now it is recording, Amma. The recording option is full.
Yes, ma'am.
Okay, ma'am. So in first unit, we're going to learn what are the concept means, data types, variables, arrays, classes, inheritance, package, interface, and exception handling. In second unit, we're going to learn about multi-threaded programming, string handling, and then IO operations. And third unit, we're going to learn collection framework, and then we're going to learn about event handling mechanism. And the fourth unit, we're going to learn about swing. So the textbook is the complete reference 11th edition. All of you refer only the 11th edition book, because more variations are there between even 10th edition and 11th edition. Because every year some improvements are introduced in Java programming, so that all are incorporated in 11th edition book only. So all are try to refer 11th edition book. I have a ebook, and you can also download this ebook from net. So if you need this book, ebook, I will send that link, or I will send the PDF to you. Send the PDF in your classroom, Google Classroom. You can refer. But more editions are available in NetPub, 5th edition, 7th edition. More editions are available, but all are try to refer only the 11th edition. So directly we get into the concept, history and evolution of Java. So the day by day, some new concepts are introduced in programming language. The reason for that, to adapt to changing environment and users, to implement a refinement and improvements in the art of programming. So because of these two reasons, that programming languages are changed day by day. And while we develop a programming language, while one new programming language is developed, at that time they have to consider these three things. So ease of use versus power. That means that programming language must be easy to use, and it also use less power. And next, the second one is that programming language must be secured programming language, and it is also must be efficient programming language. The programming language must be rigid as well as extensible. So while we design, or while someone design programming language, they must consider these three points. So first, initially, which many languages are developed before Java programming. That languages are Fortran. So it is efficient but not suitable for system programming. So by using a pointer concept in C and C++, we can develop our own system programming. What does mean by system programs? System program means we can develop a compiler, we can develop one new OS. So that type of programs are called system related program. So what does application program means? If you develop any app for library or some university, if you develop some app for university, that are all normal application program. So system program means a compiler, that and all system program. So by using this Fortran, we cannot develop any system programs. So next, basic. So basic language, it is easy but not that much a powerful language. Assembly language, so it is very efficient language, but it is not easy to learn and debug. So only the person who are expert, so that they can only learn assembly language, and they can only write the program, and they can only debug the program. And the basic COBOL, Fortran are all languages, but it is not programming languages, but it is not structured programming language. And it is also, these languages are all have go-to statement. So go-to statement means this will make the program to understand difficult. For example, program written in these language will form a spaghetti code. So what does mean by spaghetti code? These programming languages are all have a go-to statement. No? So if it have a go-to statement, the mass of tangled jumps and conditional branches may be introduced in programming language. So this will make the program virtually impossible to understand. So this type of code is called spaghetti code. So what does mean by spaghetti code? A mass of tangled jump and conditional branches. So these are all called the code with the mass of tangled jump and conditional branches means the code is called spaghetti code. The next, the structured language is Pascal. So this is a structured language, but it is not efficient. The basic COBOL, Fortran are not structured programming language, but Pascal is a structured programming language, but it is not efficient. So next, the language, the high-level language C was introduced, as that is a structured programming language. So this replaces the assembly code when creating system programs. So usually before C programming, if you want to develop any system program means you have to use assembly language. But if you are using assembly language, it is very difficult to write and difficult to debug. So that's why the next high-level language C was introduced. By using C language, you can develop your own compiler, or you can develop any OS. You can write OS or something. But this C is a structured programming language, but it is not object-oriented programming. So by what does mean by object-oriented programming means that should be used for a real-time application. So here, all the things to be considered as an object. So then only the language is called OOPS. So C++ is a OOPS language, that is object-oriented programming language, because of it have the concept inheritance, encapsulation, and polymorphism. So by using these concepts, we can make use the C++ for real-time application. And first, initially, binary machine language, machine instructions were developed, and then assembly languages are developed. After that, unstructured high-level languages are developed. Example, Fortran, COBOL, example, Fortran. And then next, structured high-level language developed, that is C. After that, object-oriented programming is developed, that is C++. The first object-oriented programming is C++. So after that only the Java was developed. Java is a fully object-oriented programming language. So why we move from C++ to Java means Java is platform independent. So what does mean by platform independent means you write once and run anywhere. So what does mean by write once and run anywhere means in C++, if you want to execute your code in Unix platform, or if you want to execute in Windows platform, or means you have to write some modification, you have to do some modification on your code. But in Java, you no need to do any modification in your coding part. So that single program that can be executed in Unix platform or Java Windows platform or any other platform. So it is a platform independent. And also for compiling C program and C++ program, you need a different compiler for different platform. But in Java, we don't need a different compiler for different platform. If in design C++ compiler for each architecture, but it's time as well as cost consuming approach. So if you are using a different compiler for a different architecture means it will cost consuming approach and also time consuming approach. And so main advantage of Java programming is platform independent, right? Write once and run anywhere. So the single code that can be executed in any different platform. You no need to do any changes in code part. And then the mainly Java is used in internet, so that the Java codes are all can be transferred over the internet and it can be executed at the client machine. But in C are all not suitable for internet programming, but Java is suitable for internet programming because the Java codes are transferred over the internet and the code can be executed at the client machine by using Java enabled web browser. And the Java was conceived by James Gosling, Patrick Norton, Chris Worth, Ed Frank, and Mike Sheridan at Sun Microsystems. So it was developed at Sun Microsystems. So when it is developed, it was called as Vogue in 1991. So after that, it is renamed as Java in 1995. And what is the relationship between C# and Java means? C# and Java both are maximum both are same. The syntax wise, execution wise, both are same. But it is C# is a Microsoft product to support a .NET framework. How Java program are used in internet means, for that here one new concept was introduced that is called applet. So by using that applet is nothing but Java program. Applet is nothing but a special kind of Java program. So that can be transferred over the internet and automatically it is executed by the Java compatible web browser. So that applet is downloaded on demand. So what is mean by downloaded on demand means, if the user click the link that contains an applet, that applet will be automatically downloaded and it is executed by the Java enabled web browser. So in network, in internet, two types of objects are there. One object is called passive object. Another object is called passive object and active object. So what does mean by passive object means that example for passive object are email. Here by using this you can just read the message. So this won't perform any action on client machine. So you can just read the message. What does mean by active object means that active objects are all run in the client machine. So it will do some changes in the client machine. For example, dynamic active program means that are dynamic active program. So what is dynamic active programs means? Self-executing program. Act as an active agent in client machine and it is initiated by the server. So here applet is a dynamic self-executing program. So what is the difference between normal program and applet program means? A normal program that downloads and executes automatically on the client computer. It may harm because it may access the resource of the client machine. But that applet does not have the rights to access the resource of the client machine. So it won't create any harm at the client machine. So it can, the normal program cannot run in a variety of different environment and under different operating system. So these are all solved by applet program. But now we are using the current version of Java. We don't have this applet. Instead of applet, we're going to use some other concept. So we will see that later. But initially, they have for internet programming, they have developed an applet. For internet programming, they have developed an applet. But now we don't have applet concept in Java. Up to JDK, we will see what is JDK 1.8, 1.9 and later. Up to JDK 1.8, this applet will be executed. Applet is executed. After JDK 1.8 version, that applet program won't be executed. And then The main purpose of applet is security. So normal program, I told you, downloading a normal program might contain a virus, Trojan horse, or other harmful code. That malicious code can cause its damage because it has gained unauthorized access to system resources. Normal program means that can gain unauthorized access to system resource. But that applet program does not have unauthorized access. Java achieved this protection. Java achieved this protection by confining an applet to the Java execution environment and not allowing it access to other parts of the computer. That applet cannot access other parts of the computer. And another main advantage of this Java is Java applet is portability. Portability means that the same applet can be executed by the wide variety of CPUs, operating system, and browser connected to the internet. And then these are all the important concepts in Java. Usually, while you compile the programming language, after compiling, you will get one object code, that is executable code. So after compiling any code, you will get executable code. But in Java, after compilation, you will get one intermediate code. That code is called bytecode. Because of this bytecode only, Java is platform independent. Because of this bytecode only, Java is platform independent. So normally, if you are writing a C programming, so after writing that C programming, what you will do, you are going to compile that code. So after compilation, what you will get? You will get one executable code that is called object code. So then that object code is executed. But here in Java, after compilation, we will get, instead of executable code, we will get one intermediate code. That code is called bytecode. So this bytecode is highly optimized set of instruction, and this bytecode can be executed by the Java runtime system. So that is called a Java virtual machine. So this bytecode is executed by Java virtual machine. So Java JVM, that is Java virtual machine, is also called JVM. So the JVM is an interpreter. So I will explain what is called compiler and what is called interpreter. So compiler means the compiler go through the full program. If there is any error, and then if it will mention the errors. So after correcting that error, if you compile again, then it will convert that to executable code. So compiler means it go through the full program once, and if there is error, and if there is an error, it will mention that error. But interpreter means it will convert the code to machine code line by line. For example, if I have a 5 statement in my program, means the first statement is converted to executable code, and second statement is also converted to executable code. If I have any error in that third statement, it will stop there itself. And it will mention the error. After correcting that error, then it will create object code for the third statement. Compiler means it will go through the code fully once, and if there is an error, if stop it won't create object code. If you correct the error, then only object code is created for that particular program. But interpreter means it will convert the source code to executable code line by line. So if first statement there is no error, it will convert it to object code. Second statement there is no error, it is converted to executable code. If there is an error in the third statement, it stop the conversion. It mentioned the error. After correcting that error, then it will convert the third statement to executable code. So that is the difference between interpreter and the compiler. So first Java is compiled. Java code is compiled by the compiler. So that compiler will create one special code that is called bytecode. So then this bytecode is executed by Java virtual machine. So this Java virtual machine is interpreter. So this Java virtual machine is interpreter, but Java is platform independent. Java bytecode is platform independent, but this JVM is platform dependent. This JVM is platform dependent. So JVM will differ from platform to platform, all understand the same Java bytecode. So here, how Java is how we are making Java as a platform independent means by using this JVM. Because this JVM is platform dependent. This JVM is platform dependent is a very important question. JVM is platform dependent, but bytecode and the Java code. The Java code is nothing but the source code. So first we have to write the source code. So we have to compile the source code, then we will get the bytecode. So this bytecode is executed by JVM. So the Java source code and bytecode are all Java platforms. That's our source code, and the bytecode are platform independent, but this JVM is platform dependent. So JVM will differ from platform to platform, all understand the same Java bytecode. And here, the JVM itself, we have one compiler. So that compiler is called just-in-time compiler. So what is the purpose of this just-in-time compiler means? It is used to improve the performance of the JVM. So I will show you one example how it will improve the performance of Java. So here an example for compiler. Tell me, ma'am.
Ma'am, we already have a interpreter. Then why do we need a compiler, ma'am?
That just-in-time compiler, Amma. You are asking about just-in-time compiler?
Yes, ma'am.
I will explain, ma. I will explain. First, the source code is there. Java source code. So we have to compile that by using Java compiler, ma. We have to compile that by using Java compiler that will convert to bytecode. And then this bytecode is executed by JVM, Java Virtual Machine. So within this JVM, we have a Java just-in-time compiler. So what is the purpose of this just-in-time compiler means? It is improve the performance of the JVM. I will explain how it will improve the performance of JVM through one example. Wait, I will explain.
Okay, ma'am.
Here is an interpreter. So here I have a statement. Totally, I have a 6 statement. So that first statement, there is no error. First statement, there is no error. So it will convert that to machine code. And then second statement is also there is no error. So it will convert to machine code. But third statement, I have an error because that Z is declared at the line number 4. But before line number 4, I try to use that variable Z. So here I will get an error. So here itself it stop and it show the error message. So after correcting that error, then only it will convert this third statement to executable code. So this is interpreter. So it will convert the source code line by line it will convert the source code to object code line by line. So what does mean by compiler means? What is mean by compiler? In C language and C++ language and all, we are using a compiler. So if the compiler go through the full program, So if there is an error in our program, for example, here are 2 errors are there. One is a third statement, another one is 5th statement. So here Z is declared after third statement and there is no variable A here. So here we have a 2 error message. So it will show all the errors available in that program. So after correcting all the errors, then only it will convert the program to object code. So after correcting all the errors, but here after correcting this error, so this code is converted to machine code. After that, this will convert it to machine code. So then here is an error. So what interpreter will do? It will show the error message here. So after correcting this error, then it will convert. But in compiler, after correcting all the errors of that program, then only executable code is generated. So now we will see how this compilation and interpretation are happened in Java programming. So this is an Java. It is not a Java programming. You assume this is an Java program. It is compiled. After compile, This is not a example for a Java programming. So if after correcting that error, then compiler will generate executable code. So after correcting that error, then compiler will generate an executable code. So now we see how this compilation and executions are performed in Java. So this is not a Java code. You assume this as a Java code. So first, this is compiled by Java compiler. So the Java compiler is called Java C. So first it is compiled by Java compiler. So after compilation, what we will get? We will get one intermediate code that is called bytecode. So here the Java program and bytecode are platform independent. So then this Java bytecode, then this bytecode is executed by the interpreter Java virtual machine. So within that we have one just-in-time compiler. I told you, within Java virtual machine we have one just-in-time compiler. So what is the purpose of this just-in-time compiler? It will improve the performance of JVM. So this JVM, what this JVM will do? This JVM will convert this bytecode to object code line by line. Before that, this just-in-time compiler go through the full code. If it can improve the performance of this code, it will improve the performance. For example, here we have a 3 byte code, that all 3 byte code are same. So this now what this just-in-time compiler will do means this instead of compiling 3 statement, it is going to compile, it is going to find out the mission code, executable code for this statement, and automatically that mission code is replaced for these 2 statements. So like wherever this type of statements are there, the same statements are there, just-in-time compiler will replace us the mission code. Instead of finding a mission code for each and every statement, once it is find out the mission code for that statement, it replaces the mission code wherever the same statement are occurred. So like that, it will improve the performance. Now you understood, Appa? Hello?
Yes, ma'am.
Now you understood what is the purpose of just-in-time compiler.
Yes, ma'am, I understood, ma'am.
Just-in-time compiler just to improve the performance of interpreter.
Ma'am, I'm actually having a doubt, ma'am.
Tell me, ma'am.
Ma'am, at which stage we should rectify the errors, ma'am? It is after Java compiler or just-in-time compiler or interpreter?
No. While it is generating the byte code,
Yeah,
after correcting all the errors, then only the full byte codes are generated. First we are compiled by using Java C compiler,
Yes, ma'am.
If there is an error at the third statement, only bytecode is generated for first 2 statements. By using that 2 bytecode, we cannot execute the program.
Okay, ma'am.
So once a full bytecode are created, then only we can execute. So during compile time, during the Java compilation, that time only we will find out the errors in the program.
Yeah, okay, ma'am.
And then one more concept called servlet. So the servlet is a small program that executes on the server. So applet is a program, that applet is also a small program, but that is executed at the client side by using Java enabled web browser. But here a servlet is a small program that execute on the server. For example, servlet are used to create dynamically generated content that is then served to the client. So we will see one example. So an online store might use servlet to look up the price for an item in a database. Instead of applet, if they are using a servlet, the price information is then used to dynamically generate a web page that is sent to the browser. That is the generations are happened at the server side and the result is sent to browser. But applet means that applet program that itself executed in client machine and it will produce the result there itself at client machine itself. But servlet means the program are executed at the server side, then the result is sent to browser. So this is one example for servlet. Even we have many common gateway interface. We are using servlet because it increases the performance. Because the Java servlet means it platform independent. And the advantage of Java, why we are using Java programming means it is a simple, secured, portable, object-oriented, robust, multi-threaded. So we will see one by one. So why it is simple means, so if you are very familiar with the C++, so writing Java program is very simple. So you don't worry, you don't know, I don't know C++, then how can I learn Java? So you don't worry, I will teach from basic concept. But those who are very familiar in C++, they can easily learn Java because most of the syntax of C++ and Java are same. So that's why it is simple and object-oriented. So here this is a fully object-oriented. Everything is object. But here everything is considered as object. In C language, that main function where you in C++, where you write the main program outside of the class. So the main function should be always outside of the class. But in Java, the main function itself that should be within class. So that's why here the Java is called fully object-oriented programming. So here everything is considered as an object. And then this is robust. Why it is called robust means strict compile time and runtime checking. In C++, once if you allocate the memory, you have to deallocate manually. Otherwise, what will happen? The memory leak problem will happen. Once if you allocate the memory by using malloc, in C language by using, if you are allocating memory by using malloc, you have to free the memory by using free. I thought the function free. But in C++, if you allocate the memory by using new operator, you should deallocate by using delete operator. But in Java, you don't need to delete the memory manually. Here, automatically the memory are deleted by using a garbage collection. One concept is there that is called a garbage collection. So that remove the object automatically. That remove the unused object automatically. Okay, Java provides object-oriented exception handling. So in C++, also we have exception handling mechanism, but that exception handling mechanism is not object-oriented. Here, Java is fully object-oriented programming. So you don't worry, we will see exception handling mechanism later. But here, that exception handling mechanism is also object-oriented programming. And there is no concept in multi-threaded programming concept in C++. But here we have a multi-threaded programming. So what is mean by multi-threaded programming? So we can execute more than one sequence set of instruction at a time. More than one sequence set of instruction at a time. So that is called a multi-threaded programming. So by using this, programs that do many things simultaneously. Wait. I cannot move to next slide. So wait, I will check it. The next one is architectural neutral. So why it is called architectural neutral?
Ma'am, ma'am, we're not able to see the PowerPoint.
Oh, wait. Once again, I will share the PPT. And now we able to see the PPT, ma'am?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Next, Java is architecture neutral. So why it is called architecture neutral means it is a platform independent language, So that means write once, run anywhere, anytime, forever. So in C++ means you have to write a different code for different platform, but Java means once if you written that code means that can be executed in any platform. So interpreted and high performance. Why it is interpreted? Interpreted is by JVM, and then why it is high performance means because of using a just-in-time compiler. And then here in Java we have several concepts for networking purpose. So that is a TCP/IP protocol. So that and all we will see later. So Java is distributed because of TCP/IP UDP protocol. And here one new concept RMI, remote method invocation. So this feature enables the program to invoke the method across a network. So this time, but in your syllabus, we don't have this RMI and this TCP/IP protocol. So next year, you're going to learn networking concept. So in that networking concept, you're going to read all these concepts, remote method invocation, TCP/IP protocol, all those things. So then only you can clearly understand about this concept. So without the introduction of networks, if we teach these concepts, you cannot easily learn. And the next one is dynamic. So in Java, Java dynamically linking new classes, libraries, methods, and objects. So that's all. Today class introduction. If you want to discuss anything with me, I will come through a video. Wait. Hello. Hello, ma. How did you feel, pa? This video lecture. Are you feel comfortable?
Yes, ma'am.
Are you
Yes,
feel
ma'am.
comfortable? Or I want to make any changes? You tell me. I will do the changes, ma. You tell your opinion, ma. Today class is okay. The speed and that clarity of explanation, that and all okay, or I have to improve something, ma, because face to face I can feel your expression and then I can change the style, but now I cannot see your faces. You tell me, ma, it is okay?
Yes, ma'am.
Okay. From chat window, many of them are saying comfortable. Okay. Thank you, pa. Thank you. The 2 days, some introduction classes. The later we will see how to write Java code. You don't worry. You don't know the C++ concept like that. You don't panic. I will explain from only through basic concept. Many of them may be familiar in Java programming. For those people, you wait, we will see concept later. But initially, I will start with some basic concept. Okay. Okay. Any other feedback you want to tell? You post it to my mail. You send me to my mail. Okay, do you know my mail ID, no?
Ma'am, share this PPT to Google Classroom, ma'am.
Okay.
PPT and this recording also.
Recording. Okay, ma. I thought that first 2-3 class recording, you know it, but no problem. Even though I will send it to you. First 2-3 class, only introduction class, no? That PPT itself enough for you, I thought. But even though I will send you the link. Recorded
Okay,
link.
ma'am. Okay.
So many video links if you are having now, it is at last minute it's difficult to learn. Only I will send that important video links and which PPT itself you can learn by yourself. Now I will send only the PPT. Is it okay?
Yes, ma'am.
Okay, ma'am. Yes, ma'am.
Okay, ma'am.
Okay.
Last time for most of you I handled C++.
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
Okay, but
Yes, ma'am.
last time only we learn up to inheritance concept, in classroom.
Yes,
Friend
ma'am.
functions, up to friend functions.
Yes, ma'am.
Only we have started inheritance. Okay. Okay, don't worry. We will meet you. We will meet soon in classroom, not in Google
Sure,
Classroom, in Shastra classroom. Hope we will meet. Huh? Okay, but thank you, ma.
Ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Bye, ma'am.